We may finally understand why clouds are different between Earth's hemispheres. That's a thing? You might think that clouds are clouds all over Earth, but that's not quite so. If you're in the southern hemisphere, the clouds there are different, more abundant, and more reflective than clouds found in the northern hemisphere. A fact scientists are well familiar with, but have not been able to fully explain why. Now, new research sheds more light on why clouds work differently in the two hemispheres, and in particular the role that updrafts play, the upward motion of warm air that leads to condensation and formation of clouds. The study used 3 years of LIDAR and radar data, 2018 to 2021, covering Leipzig in Germany, Limassol in Cyprus, Punta Arenas in Chile, and the latter case the longest dataset ever collected in the region as part of Da Capo PESO Dynamics Aerosol Cloud and Precipitation Observations in the pristine environment of the Southern Ocean. What makes the region so pristine, and this extends to the Southern Hemisphere as a whole, is that a high percentage of it is ocean rather than land. And that means cleaner air, fewer aerosol particles for cloud droplets to freeze around, and brighter clouds. Clouds ice up much less in the mid latitudes of the southern hemisphere and contain more liquid water in the same temperatures, says meteorologist Patrick Seifert from Leibniz Institute of Tropospheric Research, Tropos in Germany. He says this means that they influence the incident sunlight and also the thermal radiation emitted from the Earth's surface differently than in the north. The study found that the differences were most pronounced in the free troposphere, air massed at higher altitudes where it's less affected by local pollution. For temperatures between minus 24 degrees Celsius and minus 8 degrees Celsius, that's minus 11.2 Fahrenheit and 17.6 Fahrenheit, clouds over Punta Arenas formed ice, an average of 10 to 40% less often than clouds over Leipzig, Germany. This matches neatly with previous research, but the team also discovered something new. So-called gravity waves, uplifts of air created as westerly winds from the Pacific collide with the Andes, are an important factor as well as atmospheric pollution, especially when the air is even colder. By measuring the upward and downward winds within the clouds, we were able to detect clouds that had been influenced by these waves and filter them out of the overall statistics, says meteorologist Martin Radnes from Tropos. He says this allowed us to show that these gravity waves, and not the lack of ice nuclei, are mainly responsible for the excess of cloud droplets at temperatures between minus 25 degrees Celsius, that's minus 13 degrees Fahrenheit. The next question is whether this is exclusive to the landscape of Chile or whether gravity waves are having an impact over the open ocean. Further measurements will be required to figure out how much of the excess liquid water in clouds is down to updrafts and how much is down to ice crystals. These differences are all very intriguing on their own, but there is a problem. Global climate models are not accurate enough when it comes to representing the radiation balance of the southern hemisphere, the researcher said. To be as useful as possible, already complex climate models need to factor in regional differences, whether that's built up urban areas like Leipzig, Germany, areas with clearer air like Punta Arenas, or areas with mix of human-made pollution and natural desert dust particles like Limassol, Cyprus. Part of the discovery was down to chance, the researchers report, because of travel restrictions imposed by global pandemic. They kept their monitoring systems in place for about an additional 2 years, which enabled them to factor in extra influences such as wildfire smoke drifting over from Australia during 2019 and 20. With Da Capo PESO, we have filled a gap in measurements that has long existed for southern hemisphere, says atmospheric scientist Boris Barja from University of Magallanes in Chile. The freely available data can now help to improve current climate models, he said. The research was published in Atmospheric Chemistry and Physics. This was originally published by Science Alert and it's on Collective Spark. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.